Welcome to qnawire.
For this problem on the topic of analysis of structures, we are shown a truss in the diagram and we are told that it is supporting an advertising panel. We want to find the force in each member of the truss for a load equivalent to the two forces shown. We want to state whether each member is also in tension or in compression. So if we look at the free body diagram for the entire truss and we take anticlockwise moments to be positive, if we take the sum of the moments about point F, this must equal to 0 since the system is in equilibrium. And these moments are 800 newtons times 7.5 meters plus 800 newtons times 3.75 meters minus A times 2 meters must equal to 0, which means that we can find A, and we have the magnitude of A to be positive 2,250 newtons. So the vector A is 2,250 newtons vertically upward. Now, using this free body diagram, taking the upward direction as positive, we can also take the sum of the forces in the y direction, and this is also equal to 0, since there's no net motion in the y direction, and hence we get 2,250 newtons plus the y component of force F, Fy, is equal to 0. This means that Fy is obviously minus 2,250 newtons, or 2,250 newtons vertically downward. Lastly, if we take the right direction as positive and sum the horizontal components of the forces, again, we need to get 0. And so we get Fx, or if we perform this calculation, we get this to be minus 800 newtons minus 800 newtons plus the x component of F is equal to 0, which means that the x component of F is simply positive 1,600 newtons. And so Fx is equal to 1,600 newtons, and that's to the right. That's the vector. Now let's look at joint D. So we've drawn a free body diagram for joint D as circled here. Now, from this free body diagram for joint D, we get the following. At joint D, we have 800 newtons divided by 8 with some simple geometry is equal to F dE over 15, which is equal to F BD over 17. This allows us to find two of the forces that we require immediately. So we get F BD to be 1,700 newtons, and that's compression, and we get F dE to be 1,500 newtons of tensile force. So we found two of our forces that are required. Next, we look at joint A, and we'll draw a free body diagram for joint A as we have here. And from this free body diagram for joint A, we have the following by geometry, that 2,250 newtons divided by 15 is equal to F AB over 17, and this is equal to FAC over 8, which again means we can immediately find FAB and FAC. So FAB is equal to 2,250 newtons, and FAC is equal to 1,200 newtons. FAB is compression and FAC is a tensile force or tension. So there we have the next two of our forces. Now let's look at joint F. So we've drawn a free body diagram for joint F as well. And from the free body diagram for joint F, we can first take the right direction as positive and sum the x component of all the forces. And this must equal to 0 from equilibrium. And that's 1,600 newtons minus F CF is equal to 0, which means that F CF is equal to 1,600 newtons, and this is a tensile force. Now we can look at the vertical components from this free body diagram as well, and we'll take the upward direction as positive. So if we take the sum of all the forces acting along the y direction, again this must be 0, and this is F EF minus 2,250 newtons, and that must equal to 0. So again, we can immediately find F EF to be 2,250 newtons, and this again is a tensile force. So this member is in tension. Next, we'll look at joint C. And if we go to our free body diagram for joint C, which is circled here, we can again look at horizontal and vertical components of joint C, and we have that if the right direction is positive, the sum of the forces in the x direction must equal to 0. So that is 8 over 17 F CE minus 1,200 newtons plus 1,600 newtons must equal to 0, which means that FCE is negative, and we get negative 850 newtons, which means that FCE is 850 newtons, and it's a compressive force. Again, we can look at now the y components, and the sum of these components again must be 0 since there's no net motion in the y direction, and this gives us F BC plus 15 over 17 FCE is equal to 0. Now we already know that FCE is 850 newtons, or minus 850 newtons in this case. So rearranging, we find FBC to be positive 750 newtons, or 750 newtons in tension. So now we have the member force FBC. Now finally, we have joint E. And we have a free body diagram for joint E as well. And from the free body diagram of joint E that is circled, we have, again, taking the right direction as positive, that the sum of the forces in the x direction must equal to 0. So this is minus FBE minus 800 newtons plus 8 over 17 times 850 newtons must equal to 0. So this allows us to find our final force, FBE, and FBE is negative, so it's a compressive force, and FBE is equal to 400 newtons of compression, and that's our final force.